Hello, we're going to demonstrate this wound rotor motor controller. So we've got our 1.5 horsepower wound rotor motor, we've got our flywheel, and we've got our eddy current brake to add some extra load. We've got the eddy current brake set so that at full speed it's going to be drawing full current. So that would simulate the load that we want to start with this motor. Here we've got an amp meter on the line current, so we'll be able to see the line amps. We've got a frequency meter on the rotor circuit, so we can see the frequency of the rotor. Should start at about 60 hertz and then drop as the motor accelerates. And we've got indicating lights that show when the main M contactor closes and when the resistor bypass contactors close. We have 3 stages of starting. We have the initial stage where we're only energizing the M contactor, applying 3-phase power to the stator. Then after a delay, we're going to remove some of the rotor resistance. Then after the next delay, we're going to remove the remainder of the rotor resistance. So we'll be able to see when those contactors energize. Here are the time delays. We can adjust the time delay to delay when we bypass these resistance values. Okay, here we go. So it started at 60 hertz. We've got full resistance in the rotor. So now we just remove some of the resistance. So now we're at about 8 amps. Now we remove the rest. It's accelerating. And it should settle at about 5 amps. And when we bypass the resistance, we shorted out these 2 wires as well. So the resistance or the frequency of the rotor is probably 4 to 5 hertz. And the speed, is about 1700 RPM. So it's running at a fair bit of slip. If I remove the load, or about 1300 RPM. A little over 1300. That's with the same load we had on it before. And our current is still at about 4.8 amps. So the speed did decrease, but we are creating less torque because the speed went down. So I'm going to go to 50%. Well, our rotor frequency, you can see, is about 20 hertz. So you could figure out what the slip is. The math pretty much works out. So I'm going to go to the 50% setting. So the motor is going to decelerate. The slip or the frequency is going to increase. Therefore, the slip is increasing. And we'll see where that settles down. go back, so that's with no full resistance in the rotor circuit. I'm going to go back to 75%. The frequency on the rotor, once the contactor kicks in, it's going to accelerate. The frequency of the rotor is going to decrease. And should settle in at about 20 hertz. Now we should go back to about 5% slip after the time delay. When that light comes on, that's when we take all the resistance out of the rotor. So we can hear it accelerating. You can see the frequency of the rotor decreasing or going to zero because it's basically shorted out. But our speed, rating of 4.7 amps. That gives us 1715 RPM right now. Going at half the speed is because if we look at this drawing, this starter was calibrated for this specific motor with resistance values that brought us to those speeds. So this has been engineered to work at 100%, 75, and 50% speed. Now, we probably wouldn't use this as a speed controller anymore. There's much better ways to do it, but it's still capable of doing this.